Hello everyone and welcome to my YouTube channel. So here today we are going to be looking at partial fractions. So under this topic we are going to cover each and everything that you need for your exam under partial fractions. So what is partial fractions? So sometimes you may be required to simplify certain fractions, but the partial fraction is doing the opposite. Like for example, if we have a number such as, so let's say we are required to simplify this. So to simplify this, we recall that what we are just going to do is that we are going to take both of these, they are going to be our denominator. So we are going to open the brackets, write this first one, 3x plus 1, and write this second one, which is our x minus 7, like that. And then from there, what this means is that this first denominator multiplies that, so we are going to have a 7 multiplies 3x plus 1. Then this second denominator multiplies this one, so we are going to have this 3 multiplying our x minus our 7, like that. Then what we are going to have is that we have our 7 plus times 3, that will give us a 21x. 7 times 1, it will give us plus 7. Then our 3 times x, it will give us our 3x, like that. 3 times negative 7, it will give us a negative 20. So this is going to give us a negative 21, like that. Then what we are going to get is that over, we have our 3x plus our 1, our x minus 7, like that. So as we subtract this, we are going to get we have 21x, 7 minus 21. So we are looking at the like terms. So the like terms are such that 21x plus 3x, it will give us 24x. 7 minus 21, so 7 minus 21 will give us a value that is equivalent to negative 14. So we are going to write our negative 14 over, we have our 3x, like that, plus 1, and our x minus our 7, like that. So now this is us simplifying. Now under partial fractions, we'll be required to reverse the equation. So how do we reverse it? So all we have to do is write the 24x minus our 14 over our 3x plus our 1. Then we multiply by our x minus 7, equates this to the unknown number that was there, a, over the first denominator, which is our 3x plus our 1. Then we are going to have plus, then we are going to multiply the second number, the second unknown number, over our second denominator, which is going to give us our 7 minus x. So remember, initially it was 3 over this, but we don't know the number that is here, so we replace a, here we replace b, like that. Then after doing that, what we are going to do is that we are going now to get rid of this. So how do you get rid of this? It is simply by multiplying this same thing throughout. So we have our 3x plus 1. We multiply this by our x minus our 7, like that. Then when we multiply this throughout, we are going to find that this one is going to be cancelled. So this is the same as having our 3x plus 1 times. So I'm only going to do this once. So we have times already, whatever number is here, but let's just put 1. This is just for the sake of understanding. We have our 3x plus 1 times our x minus 7, like that. You will find out to say this term cancels with that term, this term cancels with that term. So that's the essence of doing that. So after we do that, we are going to end up with this one cancels with this. So this one cancels with this one cancels with this. We are going to have our 24x minus 14 should be equal to, we have our a, like that. Then on the latter part, so this number is multiplying everything. You are going to find out to say this one cancels with this one, like that. Then what we are going to remain with is our x minus 7, like that. Then for the second part, we are going to find out to say this 7 cancels out with that. Then we are going to have plus our b like that. Then open brackets, we have our 3x plus our 1 like that. So after doing that, we are going to have our 24x minus our 14 should be equal to, so we have that term. So in other words, after reaching this stage, you are going to let, so here you are going to let x be equal to, so the essence of letting x be equal to something is that you want to eliminate one of the letters. So there is a and b, so you want to eliminate a or b. So how do you do that? So this is simply through, you are going to look for a number that will give you 0. So here, for example, when you put a 7 here, you are going to have, when x is equal to 7, here you are going to have a 7 minus 7, which is going to give you 0. This is what you want to achieve. So you are going to let x be equal to a number. So to find this number, just get whatever you want, equate it to 0. So x minus this is equal to 0. Take the value there, then it will give you x is equal to 7 like that. So after you do that, what we are going to have is that we are going to get a 24 where x is, we are going to put a 7 like that, minus our 14 should be equal to, we have our a 7 minus 7 we are replacing, plus our b where x is, we are going to have 3, our x is 7, then we have plus our 1 like that. Then what we are going to end up with is, so what we are going to get is our 24 times 7. This will give us, we have 8 here, 8 remainder 2, this times this is 14 plus 2, that will be 168. So we are going to write our 168. So we have 168 minus our 14 should be equal to a, 7 minus 7 is 0, then we have plus our b, we have 3 times 7, it will give us a 21, then we have plus our 1 like that. So after doing that, we are going to end up with 168 minus our 14, this will give us a 154 should be equal to, so 0 times a is 0, then we are going to remain with 21 plus 1 is 22, then attach the b like that. So we are going to divide our 22 there, we are going to end up with 154 divided by 22, this will give us a value that is equivalent to 7. So we have our b is equal to 7 like that. So you can reduce the value until you get the desired result. So already we have found that 154 divided by 22 is 7. Then using the other value, we are going to get this part of the equation. So now to find the value of b, or to find the value of a, we now have to set b equal to 0. In other words, we are not directly setting b equal to 0, but we want to put the value that will make the insides to be equal to 0. So this value is, you are just going to get the inside, it's 3x plus 1, equate it to 0. This is going to give us our 3x is equal to, this goes the other side, it will be negative 1 over our 3 over our 3. Then we have our x is equal to our negative 1 over 3. So we are going to let our x be equal to negative 1 over 3. So we are going to say let x be equal to negative 1 over 3. So that is what we are going to put there. So we have a 24, open brackets, negative 1 over 3 minus our 14 should be equal to, we have our a, open brackets, negative 1 over 3 minus our 7 like that. Then we have plus our b, open brackets, we have our 3 times negative 1 over 3 like that, plus our 1 like that. Then what we are going to end up with is, we have 24 times negative 1 over 3, negative times positive, it's negative. 24 divided by this 3, this is going to give us a value that is equivalent to negative 8 like that. Then we have minus our 14 should be equal to, we have a, open brackets. So here the common denominator is 3. 3 divided by 3 is 1 times that, it will give us negative 1. 3 divided by 1 is 3 times that, it will give us a negative 21, like that. Then we are going to end up with plus our b. Then what we are going to have is that we have this and this cancels. We are remaining with a negative 1 plus 1, like that. Then negative 8 minus 14, this is going to give us a negative 22, which should be equal to, we have our a, open brackets, we have negative 1 minus 21, it will give us negative 22 over our 3, like that. So what we are ending up with is a negative 22 should be equal to, this is the same as a times negative 22 over our 3, like that. So what we can do is that to eliminate the 3, we can actually cross multiply. So we are going to have 3 times negative 22, but avoid multiplying direct like that. So we are going to have negative 22 times our 3 should be equal to a times our negative 22. So divide this negative 22 so that a remains alone. We are going to have a value that is equivalent to a should be equal to, we are going to have our value of 3. So already our a value is equal to 3. Our b is equal to 7. So that means to say, for the equation that we said that it should be equal to, so we have this equation, so it should be equal to, we have where there is a, we are going to put 3 over, we have the denominator is 3x plus 1, then we have plus, where there is b, we are going to put 7 over our x minus 7, like that. So remember, this is the original equation, 3 over that plus 7 over that. So that is how we solve that one. So let's move on to our next problem. So one other important thing about answering partial fractions is that your equation, your denominator should always be factorized. If it isn't factorized, then there are other means. But if it can be factorized, you just have to factorize it. Let's look at this question. We have 8 minus we have our 8x minus our 28. We divide this value over our x squared minus our 6x plus our 8, like that. So we want to decompose this into a partial fraction. So first, make sure that your denominator is factorized, and make sure that on top there is a less degree of a polynomial. In other words, the power, it should be less than the denominator. As you can see, the highest power of the denominator is 2 here. Here it's 1. Then that means to say it's a proper equation, which you can just go direct. Now, what we are going to do is that let's factorize this. So our x squared minus our 6x plus 8. So using the same approach, we have our product, which is equal to our AC, which is equal to our a is 1 times our c is 8, which is going to give us 8. Then we are going to have our sum, which is the coefficient of b, which should be equal to, so b in this case is equal to negative 6, like that. Then we have our factors. So our factors is two numbers which when we add, they are going to give us negative 6. We multiply, they are going to give us 8. So these two numbers are, we are going to have our negative 2 and our negative 4. So these two numbers, we are going to use them. So we are going to have our x squared, where 6 is, we put these numbers. So we have minus 2x minus our 4x, then we have plus our 8. Factorize in parts. So this x is common, then we have our x remaining minus our 2, like that. Then even here, our negative 4 is common, then we are going to remain with our x minus our 2. So factorizing, it means to say we have our x minus 2 and our x minus our 4, like that. So this is the equation factorized. So for the equation where there is this, we are going to put it in factorized form. So we have our 8x minus our 28 over, we have our x minus 2 and our x minus our 4, like that. So after doing that, so this value, we are going to say that it should be equal to our a over, we have the first denominator, which is our x minus 2, then we have plus our b over the second denominator, which is our x minus our 4, like that. Then when we do that, what we are going to end up with is we are going to have something like this. Let us multiply. So you can put the multiplication either at the beginning or at the end, it's still the same. So take the denominator, multiply it throughout. So we have our x minus 2 and our x minus our 4, like that. Let me just write it properly. So now when we do that, we are going to find that when we multiply this throughout, we are going to get, so this value multiplies by this, it cancels this, it cancels this, and this cancels. We are going to remain with our 8x minus our 28, which should be equal to this one, and this one cancels. So we are going to remain with our a, open brackets, we are multiplying it with our x minus 4, like that. Then we have plus our b. So for our b, remember this value is multiplying everything. So for our b, we have this one, we have this one, and this one, they cancel. So we are going to remain with our x minus our 2, like that. Then from here, you are going to let, using the same approach, so we are going to let our x be equal to 4, like that. So what we are going to have is 8, where x is, we are going to put 4, minus our 28 should be equal to, we are going to have our a, so once we eliminate a, then we are going to have our 4 minus 4, like that. Then we have plus our b, then where x is, we are going to put our 4 minus our 2. So this is going to give us 8 times 4, this will give us a 32. Then we have minus 28, like that. Then when we do that, we are going to get a value that is equivalent to 4 minus 4 is 0, so we have a times 0, then we have plus our b, this time minus this gives us a 2. So we are going to end up with 32 minus 28, that will give us 4, should be equal to 2 times b, it will give us 2b. Then we divide by 2, we divide by 2, so our b value should be equal to a 2, like that. So we have found our b. Get the same equation again and replace another value. So what we are going to have is that when our x value is equal to positive 2, so remember first we set x equal to 4, but this time equal to 2, so that's 2 minus 2 is 0. So we are going to have our 8, where x is, we are going to put 2 minus our 28 should be equal to our a, where x is, we put 2 minus our 4. Then we have plus our b, where x is, we are going to put 2 minus 2. So we are going to have 8 times 2, that will give us 16, minus, we have our 28 should be equal to, we have our a, then we have 2 minus 4, it will give us negative 2. Then we have plus b, 2 minus 2 is 0 there. So we are going to have 16 minus 28, this is going to give us a negative 12, like that. Should be equal to negative 2 times 8 will give us negative 2a. 0 times b is 0, so we forget about that part. So what we are going to have is over our negative 2 over our negative 2, our a value should be equal to, we have a positive 6, like that. So we have found the two values. Let's just write the answer now. So what we have is, we are going to say that our 8x minus 28 over, we have our x minus 2, x minus 4 should be equal to, where a is, we have a 6 over, we have our x minus 2. Then where b is, we have a plus, b was found to be 2, so was b found to be 2, yeah, so b was found to be 2 over the denominator, which is our x minus 4. Then you have done that one. So let's move on to our next problem. So if you have this one, so this is not different, all the denominators should have more like a number on top. So we are going to say that this should be equal to, we have our a over the first one, which is just x, then we have plus our b over the second one, which is our x minus 1, then we have plus our c over, we have our 2x plus 1, like that. Then what we are going to do is that we are going now to multiply the denominator throughout so that we get, so we are going to say our x times our x minus 1, then we have 2x plus 1. So we are multiplying this throughout, so we are going to get this. When it multiplies that, it will cancel with that, then we are going to remain with our 6x squared plus our 5x minus 2 should be equal to, we have our a, then when our a multiplies that, we are going to end up with just this x cancelling with this x, then we are going to remain with two terms. We have our x minus 1, we also have our 2x plus 1, like that. Then we are going to have plus our b, like that. Then we are going to get something like this. This term cancels with that term, then what we are going to remain with is, the remaining term is this, so we are going to write our x like that, so it's connected with b. If you want, you can open the brackets, then times another term, we have our 2x plus our 1, like that. Then finally we have our plus c, we can, due to space, we can have plus our c, like that. So c, we are going to find out to say it is this term and this term that cancels, so we are going to have our c, then we have times x, it will be cx, then open brackets, we have our x minus 1, like that. So the first thing that we are going to do is that we are going to let our x be equal to 0. Why 0? Because c has got x and b has got x, so b times 0 will be 0. So we have eliminated c and b by setting our x equal to 0. So that means to say, let's substitute. We have our 6 where x is, we are going to put 0 squared, then we have plus our 5 where x is, we put 0, minus 2 should be equal to, we have our a, open brackets, we have our 0 minus 1, then we have 2 times our 0, then plus 1, then we have plus b where x is, we put 0, we have our 2, we have 0 plus 1, like that. Then we have plus our c where x is, we are going to have a 0, then we have our 0 minus 1, like that. So we are going to have 0 squared times 6 is 0, 5 times 0 is 0, so we are just going to write our negative 2 should be equal to, let's have more space, so we are going to put our negative 2 should be equal to, we have our a, open bracket, 0 minus 1 is negative 1, then we have 2 times 0 is 0, plus 1, that will give us a positive 1, then we have plus b, so 0 times b is 0 times whatever is inside, it will still be 0. So we have our b there, we are just going to have zeros, c times 0 is 0, times whatever is here is still a 0, like that. Then what we are going to have is that we have negative 2 should be equal to negative times a, it will give us negative 2a, or negative. So we have over negative 1 over negative 1. To find the value of a, we are going to find that our a value should be equal to positive 2, like that. So the next thing that we can eliminate is, so the easiest one that can be eliminated is a c. Since x minus 1 is, we can just get 1, so that it's 1 minus 1 is equal to 0, so that we can find the other value. So what we are going to have is that we are going to say when our x is equal to 1, we are going to end up with 6, where x is, we put 1 squared plus our 5, we have 1 minus 2 should be equal to, we have a, where a is, we are going to have 1 minus 1, then we have our 2, where x is, we put 1 plus our 1, then we have plus our b, where x is, we are going to get 1. Then we have our 2, where x is, we have 1 plus our 1, like that. Then this, when we do that, we are going to say plus due to space there. So we have plus our c, where x is, we put 1 times 1 minus 1. So this is going to give us 6 times 1 squared is still 6. 5 times 1, that will give us a 5. Then we have minus 2 should be equal to, we have 1 minus 1, so we have a 0 there. Then 2 times 1 is 2 plus 1, that's 3, so we have a 3 there. Then we have plus our b, 2 plus 1, because 2 times 1 is 2 plus 1, that will give us a 3, so we are going to have a 3 here. Then we have plus, we have our c, times 1 is c, then we have times 0. So already we are going to have 6 plus 5 is 11 minus 2, that's 9, should be equal to, we have 0 times 3 times this is still 0, so we are going to neglect that. The only value we are going to look at is 3b, because all these others are zeros. Then we divide by 3, our b value is found to be equal to a positive 3, like that. So then for this other one, we now require to find the value of c. We have found the value of a and b, so all we require to find is the value of c. So now for this one, we are going to find the way of eliminating our a and b. So the a and b have got one common thing, which is our 2x plus 1, 2x plus 1. So there are two ways. If you want, you can expand this, then compare. So let's do that. So we are going to get our 2x plus 1, equate it to 0 to just find out the number you are going to use. You take the 1 there, it will be 2x is equal to negative 1 over 2 over 2. So that means to say our x is equal to negative 1 over our 2, like that. Then what we are going to get is that we are going to get, so we are going to let our x be equal to negative 1 over 2. So we are going to compare for further problems. So we have our 6, where x is, we are going to put negative half, like that. Then we have squared plus our 5, where x is, we are going to put negative half. Then we have minus 2 should be equal to, we have our a, we are replacing, so negative 1 over 2 minus 1. Then we have times our 2 times our negative 1 over 2. Then we have plus our 1, like that. Then we have plus our b, where x is, we are going to put negative 1 over our 2, like that. So this is multiplying with, we have in the brackets, we have our 2, where x is, we have negative half. Then we have plus our 1, like that. So this is going to give us a value. Then we have plus our c, where x is, we are going to put our negative half. Then we have our negative 1 over 2 minus 1. Then what we are going to do is that, let's simplify. So we have our 6 times negative 1 squared is going to give us positive 1 over 2 squared is equal to 4, like that. Then we have plus our 5 times negative 1, it will be negative, in fact. So we have negative 5 over a 2. Then we have minus 2 should be equal to, we are going to get our a. Now we are going to have our negative 1 over 2, like that, minus 1. Then we have these 2 and these 2 cancels, so we are going to remain with our 1, our negative 1 for that matter, negative 1, which is this one. Then we have plus 1, like that. After doing that, we are going to get plus our b, where x, we are going to have our negative 1 over our 2. So same approach, this one and this one cancels. We are going to get our negative 1 plus our 1, like that. Like that. Then we have plus, we have our c, negative half times negative 1 minus 1, that will give us negative 1 minus 1. Common denominator is our 2. 2 divided by 2 is 1 times negative 1, it will be negative 1. then our 2 divided by 1 is 2 times our negative 1 is negative 2. So this is going to give us a negative 3 over a 2 like that. So we are going to put that. So we have a negative 3 over a 2 like that. Then after we do that, we are now going to simplify everything. So there's no need for you to find what half minus 1 is equal to, because here you have 1 minus 1 is 0, which is going to more like destroy everything. So we have 6 times 1 over 4, that will give us a 6 over 4 like that, minus our 5 over 2, minus 2 should be equal to, we have our a like that, negative 1 over 2 minus 1, then negative 1 plus 1 is a 0 like that. Then we have plus our b, same thing, we have negative 1 like that, negative 1 plus 1, that will give us a 0 like that. Then we have, last but not the least, we have our plus c, negative 3 times negative 1, it will give us positive 3 over 2 times 2 is 4. Then we have our c like that. So this is going to give us 6 divided by 4. Common, we can divide 2 on both numbers so that we remain with our 3 over 2 minus our 5 over 2. Then we have minus 2, which should be equal to, so this is 0, this is 0, so we are just going to remain with our 3 over 4 c like that. So the common denominator here is a 2, so we are going to say 2. 2 divided by 2 is 1 times 3, it will give us a 3. 2 divided by 2 is 1 times 5, it will give us a negative 5. 2 divided by 1 times negative 2, that will give us a negative 4 like that. So this should be equal to a value of our 3 over 4c like that. So when we subtract our 3 minus 5 minus 4, this will give us a value that is equivalent to a negative 6. So we have over 2 should be equal to our 3 over 4c like that. We can reduce, so we have a negative 3 should be equal to our 3 over 4. Then we have times our c. From here cross multiply, but yeah, we are going to have a negative 3 times 4 should be equal to our 3c like that. Divide your negative 3 on both numbers, you are going to remain with your c is equal to, so we have negative 1 times 4, since you divided that, should be equal to c. So we have negative 4 should be equal to c. So let's collect everything that we have gathered. So our c is equal to 4, our a is equivalent to, what did we find? Our b is equal to 3, our a is equal to 2. So 2, then b is equal to 3 like that. So let's just write it. All we have to do now is substitute. So our a value is equal to 2, we have over x, plus our b value is 3 over, we have our x minus 1, then we have plus our c over, we have so our c is equal to negative 4, so meaning to say here it should be negative 4 over our last denominator, which is our 2x plus 1 for that one. Let's look at our next problem. So let's say now we have an irreducible quadratic equation, meaning to say an irreducible quadratic equation, we are just referring to those quadratic equations which you cannot be able to factorize. So now, how do you handle that? Let's say, for example, you have this problem. So if you have this one, you cannot, no matter what you do, you cannot be able to factorize this to give you real numbers. So already, if you say x is equal to, you take x squared is equal to, this value goes the other side, it will be negative 1, the square root of this. Already you can say that your x is equal to, you're going to find that this will be plus or minus I. So meaning to say this one is irreducible, you cannot be able to factorize it no matter what you do. So therefore, what are you going to do? So you're going to say that this one should be equal to, we have our first letter a divided by the first denominator, which is our x minus 1 like that. Then already we know why we have said a over the first denominator. Then for the second one, it's a quadratic equation. So under normal circumstances, we could have a b over, let's say the first is this, if it was being factorized like that. Then we have, let's say, something like this, but it's not being factorized. So what do? So let me make things very easy for you. So already, if you look at our x minus 1, this is an equation of a straight line. X minus 1, meaning to say it's just an equation of a straight line. So if you have an equation of a straight line, on top you are having a constant, which is a might represent a constant, which when you find your answer, your a can only be equal to, let's say, 2. That means to say this is a constant. So therefore, if you have more like the power of this is power 1, on top the x power of this will be 0. 0 to the power 1 is 1. So that is how you are going to more like always remember that. So we are going to have this. Then for this one, we are going to say, since you cannot factorize it, just write it the way it is. So you first have to make sure that it cannot be factorized. Then on top, so remember, linear equation, we have a constant. So quadratic, we should have a linear equation, an equation less. So the equation of a straight line is y should be equal to, we have our mx plus our c. So this is the form. So the mx plus c is what we are going to use. Now we are just going to use different letters. So we are just going to say, since we have used a, we are going to say bx plus our c. So you can just remember y is equal to mx plus our c, like that. So immediately you have something that you cannot factorize. You can only do this if you cannot factorize it. Then after doing that, we are now going to follow the procedure that we have been looking at. So in this case, we are going to multiply our denominator there, which is going to give our x minus 1. Then we have our x squared plus our 1, like that. So what we are going to get after this is, so when you multiply this, it cancels with this, it cancels with that. We are going to end up with our 3x plus our 1 should be equal to, so for the second part, this one and this one cancels. So we are going to have our a, open brackets, we have our x squared plus 1, like that. For the second part, we are going to end up with the other part cancelling. So we have this one and this one cancels. So we have plus, we have our bx plus our c. It multiplies with the remaining, which is our x minus 1, like that. So after doing this, we can say when our x, let's eliminate 1. Let's begin with eliminating b and c by making whatever is here to be equal to 0. When x is equal to 1, that means 1 minus 1 is 0. So we are going to put 3 where x is, we have 1 plus 1 should be equal to a. Where x is, we put 1 squared plus 1, like that. Then we have plus our b, we have 1 plus c, like that. Then we have our 1 minus 1, like that. So this is going to give us a 3 plus 1, which is going to give us our a. 1 squared is 1 plus 1, that will give us a 2, like that. Then we have our plus, our b plus, b times 1 is b plus, we have our c, then times 1 minus 1 is equal to a 0, like that. So already we are going to have 4 should be equal to, we have our 2a. Then here we are just going to have plus 0 times everything here is 0, which we are just not going to write. Dividing by 2, we are going to end up with our a should be equal to positive 2. So getting the equation again, we are going to get when our x is equal to, let's say our x is equal to, which value can we use? Is there any value that can work for this one? Let's eliminate b because b is attached with x. So we can say when x is equal to 0, then we are going to have our 3 where x is, we put 0 plus 1 should be equal to a. Where x is, we have 0 squared plus 1. Then we have plus our b, where x is, we have a 0. Then we have plus our c. Then where there is x, we put 0 minus 1. So this is going to give us 0 plus 1, that will give us a 1 should be equal to, we have our a, 0 plus 1, that will give us 0. Then we have plus our b times 0 is 0. Then we have plus our c, so we write our c like that. we have our negative 1 like that. So we are going to have our negative 1, our positive 1 is equal to, we have our a negative times c, it will give us a negative c like that. Now remember, our a is equal to 2, so we are going to say, but our a is equal to 2, so we are going to put 1 should be equal to, where there is a, we put 2 minus c, we get our 2, we get it this side, we are going to have 1 minus 2 should be equal to negative c. 1 minus 2 will give us a negative 1 should be equal to negative c like that. We divide by a negative, so our c value should be equal to, we have a positive 1 like that. Then last but not the least, let's find the value of our b. Now, to find the value of b, the pressure is that there is no number that we can put for x that can eliminate a and c at the same time. So what are we going to do? So what we are just going to do is that we are going to expand then compare. So we are going to have our 3x plus 1 should be equal to, we have our a times x, it will be ax squared, plus we have a times 1, it will be our a, then we have plus, so this times this, we are going to have our bx multiplies everything, so we have our x minus 1, then we have plus our c multiplies everything, we have our x minus 1 like that. So this is going to be our a x squared, then we have plus our a like that, then we have b times x, this will give us bx squared, bx times negative 1, this will give us negative bx, then we have c times x, we are going to have our cx minus our c like that, then we are going to have our 3x plus our 1 like that. So from there, what we are going to do is we are going to compare. So get, let's say, for every term, so if we have 3x, it means to say it must be equal to all the terms that have just an x like that. So this is equivalent to that. That's the meaning. So now whatever has got, let's say our c plus our a, that will be equal to 1. That's how we compare. So just in case you are, yeah, so that's how we compare for that one. So in the other video, we are going to look at how we compare and all that using the identities like that. So we are going to say our 3x should be equal to negative bx, then we have plus our cx like that. Then we are going to have, we can divide our x throughout since it's common, so dividing x, it will be like that. So 3 should be equal to negative b plus our c like that. Then we are going to substitute. We know that our c is equal to, we know that, but our c is equal to positive 1. So we are going to say 3 should be equal to negative b, then we have plus 1. Taking the 1 the other side, it will be 3 minus 1 is equal to negative of b. Then we are going to have a positive 2 should be equal to negative b like that. We divide by negative 1, we divide by negative 1, then our b value should be equal to, we are going to get a negative 2. So if you want, you can just compare this one, the bx squared and your ax squared, as long as b is there, and you are going to say, if you get that, you are going to say your, since here there is no term with x squared, so you are going to say your 0, since x squared is there but it's just 0, should be equal to, you are going to say your a x squared, then you have plus your b x squared like that. So cancelling this, you are going to remain with 0 should be equal to a plus our b like that. Then we are going to say, we know that our b is equal to 2, we can say but b is equal to 2, we are going to have 0 should be equal to our a plus 2, taking the 2 the other side, it will be negative 2 should be equal to our a like that. Yeah, so we have found the same answer using that. So we have found our a value is found to be 2, our b value is found to be negative 2, then our c value is found to be equal to positive 1. Let's just rewrite the answer now. So we are going to substitute. So we have our 3x plus 1 over our x minus 1, x squared plus 1 should be equal to, our a is equal to 2, so over our x minus 1, then we have plus our b is equal to negative 2, like that. So we are going to say negative 2, it is connected with x, then we have plus our c is 1, then we have over, we have our x squared plus 1. So this is the required answer, but we can just write it properly to say this minus this. To avoid the ambiguity, we just interchange the positions. We have plus 1 there, then we have minus 2x. This is the same, but this negative might mean maybe you are multiplying everything. So to avoid that ambiguity, we begin with a positive, unless if there is no positive. Then we have our x squared plus 1, like that. So that is how we solve that one. Now pay attention to how the denominator is having more like a greater power. In this regard, you will find that the denominator has got x squared plus 1. Then the numerator is x to the power 1. Even if we have, let's say, we have the denominator as our x plus 1, we have our x minus 1. In the actual sense, if we have something like this, then on top we have our, let's say, 3x plus 1. Still the denominator is having the greater power, because if you expand this, it will be a quadratic, which will be 3x plus 1 over x times x is x squared. So you will find that the final answer will be this, which has got the greater power. You can just go direct to find a over something. Now this is not always the case for some problems that we are going to solve, but for now let's move on to the next part. So let's say we have the denominator with repeated linear factors. So let's say, for example, we have simplify something like our 2 over, we have our x plus 2, then we have plus our 3 over, we have our x plus 2 to the power of 2, like that. Now to simplify this is very easy. So since there is a squared, that will form our denominator, so it will be our x plus our 2 squared, like that. Then when you get this, you divide by that. It is the same as 2x squared, or x plus 2 squared over our x plus 2, in which case x plus 2 squared means our x plus 2, our x plus 2, which will cancel this, and we are going to remain with our x plus 2. So this, the remaining, it will be our 2 times the remaining, which is our x plus 2. Then x plus 2 squared divided by x plus 2 squared, this and this will cancel. Then we are going to remain with a plus 3 there. So what we have now is equivalence to, we have our 2 times x, this will give us a 2x, plus 2 times 2, it will give us 4. Then we have plus our 3 over, we have our x plus our 2, then we have our squared, like that. So this is going to give us a 2x plus 7 over our x plus 2 squared, like that. So now already we have found that. Now the challenge here is that, the challenge here is this: we have a squared, quite alright, but how do we know whether or not the original one had a linear and or had x plus 2 and squared there? So there is no way for us to know. So what we are going to do is that we are going to account for all of them. So in this case, what we are going to have is, we have our 2x plus our 7 over our x plus 2. So if we are to more like reverse this equation, we are going to get a value that is equal to, we are going to say a over, since this is the power 2, so there is a possibility of having x plus 2 plus our b. Then our b will have our more like the full package, like this. Then from there, what we are going to do is that we are going to multiply just as we did. So the denominator on this one is our x plus our 2 squared. So what we are going to have is that when we multiply throughout, this will cancel. Then we are going to remain with our 2x plus our 7 should be equal to, so here one of them will cancel. So we are going to have this times this power, and this number will cancel because there are two of these terms. So we are going to have our a open brackets, we have our x plus 2 like that, then we have plus our b, then our so each and every time we are multiplying this throughout, this whole thing cancels with this whole thing, so we are going to have plus our b like that. Then what we are going to have is our 2x plus 7 should be equal to a times x, it will be our ax. Then we have our a times 2, it will be our 2. Then we have plus our b like so. Sorry, let's put a there. Okay, yeah. Okay, let's first not do this. Then from here, let's find one of the values. Let's say when our x is equal to negative 2. So this is going to give us 2. Where x is, we have our negative 2 plus 7 should be equal to, we have our a. Where x is, we put negative 2 plus 2. So the aim was to eliminate a. Then we have plus our b. Then 2 times negative 2, this is going to give us negative 4 plus 7 should be equal to, we have our a, negative 2 plus 2 to give us 0. Then we have plus our b. So this is going to give us negative 7 plus 4, or negative 4 plus 7. This will give us a positive 3, which should be equal to, we have a b like that. So this means that b is equal to 3. Then for our a, what we are going to do is that for our a, let's get the equation. So already we have this equation and there's no way for us to eliminate b. So what we are going to do is we are just going to expand. So we have our 2x plus our 7 should be equal to, we have our ax plus 2 times a, it will be 2a plus our b. Then what we are going to do is that since b does not have any x, b must be equal to whatever doesn't have x, but it is not the only term, even this. So we are going to say our 7 should be equal to, we have our 2a plus our 2a plus our b like that. Oh, sorry, but anyways, this can still work. So we have our 7, then we can say minus, so if b comes here, it will be minus b is equal to 2a. So that 7 minus our b is found to be 3 should be equal to 2a. 7 minus 3 will give us 4 should be equal to our 2a. So our a is equal to, when we divide 2, we are going to get our a to be equal to positive 2 like that. If you want, you can just equate. This is the only one with x, equate it with the one with x, it will be your ax. Your ax should be equal to, we have your this, we divide, then we are going to get our x. Our a should be equal to positive 2 like that. So what we have here is, we are just going to substitute. So we have our 2x plus 7 over our x plus 2 to the power 2 should be equal to, where a is, we are going to put 2 over our x plus 2. Then where b is, we know that b is equal to 3. Then we have our x plus 2, then to the power of 2 like that. So this was the answer. This was the question that we had, and we have reverted the question back like that. So let's say you have this. So you are going to say this should be equal to a over the first x minus 1 plus our b over x minus 1 squared, then plus finally our c over our x minus 1 to the power of 3 like that. From there, let us multiply. So we are going to multiply the denominator, which is our x minus 1 to the power of 3 like that. Then we are going to end up with this one, and this one cancels. We are going to get our x squared plus our 2. Then we have should be equal to our x squared, our x minus 1 to the power 3. When we divide it by this one, it will be our a. Then we have our x minus 1 to the power 2 plus we have our b then our power is, we have our x minus 1 like that, then we have plus, we have our x minus 1 to the power 3 cancels with this, we have our c like that. So this is going to give us our x squared plus our 2 should be equal to, we have our a, so we have written everything there. So what we are going to do is that, let us eliminate two letters. We are going to say when our x is equal to positive 1, we are going to get 1 squared plus our 2 should be equal to a, our x is 1 minus 1 squared plus our b, we have 1 minus 1, then we have plus our positive c like that. Then this is going to give us 1 squared plus 2, that will give us 3 should be equal to, we have 1 minus 1 is 0, so we have a times 0 squared plus, we have our b times 0 plus our c. So this is going to give us 3 should be equal to, we have this times this is 0, this times this is 0, so we have our c is equal to positive 3 like that. So from there is no other way we can be able to eliminate, let's say, two letters at the same time. So we have to expand. So we have our x squared plus our 2 should be equal to, we have our a, expanding this is x minus 1 times our x minus 1, then we have plus our b, b times x, it will be bx, b times negative 1, it will be negative b, plus our c like that. So we are going to get x plus x squared plus 2 should be equal to, we have our a like that, then multiply. So we know now how to expand, so this will be our x squared minus, if you do your expansion, it will be minus 2x plus our 1, then we are going to have plus our bx minus b plus our c like that. So we are going to have our x squared plus 2 should be equal to, we have our value of 2ax squared, then we have minus our 2ax, then we have plus our a, if we multiply everything like that, then we have plus our bx minus b plus our c like that. So then what we are going to get is, when we do all this, we are going now to start comparing. Okay, so there's a mistake here, so it's just multiplying this and this and that, this and that. Then we are going to compare. So whatever has got the same powers of x, it means to say they are equal. So we are going to say our x squared should be equal to, we have our ax squared, we cancel the powers, what we are going to remain with is a 1 should be equal to a, you can just divide x squared there. Then after finding your value of a, you can also now compare with b. So b, these two should be equivalent to all the values of b. We have b, but it is not the only one without c, so we are going to say our 2 should be equal to negative b plus our c like that, which will give us our b will be equal to, we take the c this side, it will be 2 minus c is equal to negative b. So we have our 2 minus our c value is equivalent to, we found c to be equal to 3, so we are going to put 3 should be equal to negative b. 2 minus 3 will give us negative 1 should be equal to negative b over negative 1 over negative 1. Our b value should be equal to a positive, so our b value should be equal to a positive, so it should be equal to positive 1. Oh, sorry, there's a mistake. So here we need to identify all the letters that are without x. We just don't pick just a few letters. So what we are going to have is, we have something like this. So we have our 2 should be equal to all the letters without x. So this is what we have like that. So we can now say 2 should be equal to, our a value is equal to 1, minus we have our b plus our c is equal to 3. We are going to have 2 should be equal to 1 plus 3, it will give us 4, minus b, which will be, if we take this side, it will be 2 minus 4, which is equal to negative b. So this is going to give us negative 2 should be equal to negative b. So our b value, if we divide our -1 on both sides, we are going to have -1, -1. Our b value is equal to +2, like that. So we have managed to find our a is equal to 1, our b is equal to 2, our c is equal to, we have a 3. Let's write. So what we are going to have is our a is equal to 1 over, we have our x minus 1, plus we have our 2 over, we have our x minus 1 to the power of 2. Then we have our c is equal to 3 over, we have our x minus 1 to the power of 3, like that. So this is our answer for that problem. So let's say we have this problem. So how are we going to solve it? So this should be equal to, we are going to say a over the first denominator, which is our x plus 1, plus b over the second denominator, but it is squared, so we are going to have x minus 2 plus our c over our third denominator, which is going to be our x minus 2 to the power of 2. Then what we are going to do is that we are going to multiply throughout by this. So we are going to multiply by, we are going to have this, our x plus 1, then we have our x minus 2, then we have the squared, like that. So from here we are going to expand. So we are going to find that this and this will cancel, so we are going to remain with our x minus 1 is equal to this times this. So the first one will cancel with that one. We have our a, open brackets, we have our x minus 2 squared. Then also for this other one we have plus our b, then one of our powers will cancel, which will be equal to, we have this one and the power here will cancel. So what we are going to remain with is one of the x plus 1 and our x minus 2, since the 2 has cancelled, like that. Then what we have next is we have plus. If we multiply that, what we are going to get is this. So we are going to cancel this and this, then we are going to just have our c multiplying with x plus 1, like that. So from here let's eliminate 2 letters. So we have the x minus 2 is common there, so we can say let our x be equal to +2, so that we have our 2 minus 1 should be equal to a, we have our 2 minus 2 squared, then we have plus our b, where x is, we have our 2 plus 1, then we have our 2 minus 2, like that. Then we have plus c, where x is, we put our 2 plus our 1, like that. Then what we are going to end up with is 2 minus 1, that will give us a 1, should be equal to a, 2 minus 2 is 0 squared, plus we have our b, 2 plus 1, that's 3. Then we have 0, 2 minus 2 is 0. Then we have plus 2 plus 1, that's 3. So we are going to say 3c, like that. So we have 1, so this times this is 0, this times this is 0, so this should be equal to 3c. We divide by 3, we divide by 3, so our c value should be equal to 1 over 3, like that. Finding our c value, let's also find for the other values. So now we are going to easily identify. So x plus 1 is common, so we can identify our b, we can eliminate our b and c. So we can say when our x is equal to -1, that is, you just get whatever is there equated to 0. That's how you find the value. So we are going to have our, where x is, we are going to put -1 minus 1 should be equal to, we have a, open brackets, -1 minus 2 squared, then we have plus b, then we have our -1 plus 1, then we have times our -1 minus 2, then we have plus our c, -1 plus our 1, like that. So this is going to give us a value that is equivalent to, so we have -2 should be equal to, we have our a, -1 minus 2 is -3 squared, then we are going to have plus our b, like that. Then we have -1 plus 1, that's 0. Then we are going to have minus whatever we have is negative 3 there. Then we have plus c. Negative 1 plus 1 is equal to a 0, which in this case we are going to have negative 2 should be equal to a. Negative 3 squared is equivalent to positive 9, like that. Dividing our 9 on both numbers, we are going to get negative 2 over 9 should be equal to a. Let's finally find our c. So what we are going to do is that we are going to say we have our x minus 1 should be equal to, we have, let's expand this, so this is a. Then since we are going to expand, since there is no way for us to eliminate a and c at the same time without eliminating b, so we have our x minus our 2, then we have x minus 2, like that. So here we have plus our b, so we are just expanding. Then this means that this value multiplies everything, the first value multiplies everything, so we are going to have our x minus 2. Then this second value again multiplies everything, x minus our 2, like that. Then we are going to have plus c times x, it will be cx, plus our c times 1, it will be c, like that. So our x minus 1 should be equal to, we have our a, so here we are going to have our x multiplies everything, so we are going to have this x multiplies everything, it will be x minus 2. This negative 2 multiplies everything, it will be x minus 2. Then we have plus our b, like that. X times x, it will be x squared. X times 2, it will give us negative 2x. Then we have plus 1 times x, it will be x, like that. Then we have plus, or rather, where are we? So we have x squared minus 2x plus x, so we should have minus 2, like that. Then we are going to get plus our cx plus our c. So we are going to have our x minus 1 should be equal to, we have our a, x by x, it will give us x squared, minus this by this, it will be 2x, this by this, it will be negative 2x, negative by negative, it will be positive 4, like that. Then we have plus our b. Then we are going to get our x squared minus negative 2x plus x, that will give us negative x, like that. Then we are going to have minus our 2, like that. So this, then we are going to say plus our cx plus our c, like that. So from there, let's have our x minus 1 should be equal to a times x squared, it will be ax squared, minus a times this, it will be minus 2ax. So instead of doing that, our 2x minus 2x, that's negative 4x. Let's just go direct. So we have this times this, it will be negative 4, like that. Then we have plus a times 4, it will be 4a. Then we have plus our b by x squared, it will be bx squared. Then we have minus our b by x, it will be bx. This b by negative 2, it will be negative 2b, like that. Then we have plus our cx plus our c, like that. Then all we have to do from here is we are just going to compare. From here, let's compare. So comparing, what we are going to have is let's compare negative 1 with all the terms that are without x. So we have that term and this term. So we are looking for the value of b since we have found all those. So we have negative 1 should be equal to, we have our 4a minus our 2b, then we have plus our c. So we take this value the other side, it will be negative 1 minus our 4a. We take this the other side, it will be a negative c should be equal to negative 2b, like that. So we are going to get a negative 1 minus 4. If we recall, our a is equal to negative 2 over 9, like that. Then we have minus our c is equal to 1 over 3 should be equal to negative 2b, like that. So we are going to have negative 1 plus negative times negative is positive. 2 times 4, that's 8 over our 9, minus 1 over 3 should be equal to negative 2b, like that. So we are going to find the common denominator is 9. 9 divided by 1 is 9 times 9. It will give us negative 9 there. 9 divided by this is equal to 1 times that, it will be plus 8. 9 divided by 3 is 3 times 1. That's going to give us a negative 3, like that. Should be equal to negative 2b, like that. Then what we are going to have is negative 9 plus 8. That will give us a negative 1 minus 3. So negative 1 minus 3 is equal to negative 4 over 9 should be equal to negative 2b, like that. So we are going to eliminate the 2 by multiplying negative 1 over 2 on both sides, so that this negative and this negative cancels. Now we are multiplying negative 1 over 2 throughout. That means to say negative 1 over 2 times that value. So negative 1 or this times negative 1 over 2. This will give us, here it will be positive. Then this and this, we are going to have a 2 there, so it will be a 2 over 9. So we are going to get a 2 over 9 should be equal to b, like that. So we have found that our a is equal to negative 2 over 9. Our b is equal to 2 over 9. That is positive 2 over 9. Then our c is equal to 1 over 3. Let's just replace. So we are going to replace. So our a value is equal to negative 2 over 9. Then we have over our x plus 1, like that. Then our b value is equal to plus, we have our 2 over 9 over the coefficient, the denominator is x minus 2. Then our c value is equal to plus, we have a 1 over 3. Then we are going to say over our x minus our 2. Then we have a squared. Now this can be written as just the numerator, let all the denominators go down. So this is the same as having the denominators going down. So it will be a negative 2 over our x, so our 9 open brackets x plus 1. So we are just dropping the denominators. Then we have plus our 2 over, we are going to have our 9. Then we have our x minus 2, like that. Then we have plus our 1 over the 3 goes down. Then we are going to have our x minus 2. Then we have our squared, like that. Let's look at our next problem. So for this one, we have the repeated irreducible quadratic equation. So now remember what we said. The irreducible simply means to say you cannot factorize it. But let's say if it's repeating, how do we handle this one? So just as we did for that previous one, we are going to say, already we know to say on top, if this is a quadratic, come up with the form mx plus c, but just use different letters. Where m is, you're going to say ax plus our c, then over our x squared plus our 2x plus our 2, like that. But it's coming twice, so the approach will be the same. Then we are going to say plus. For this other one, we know that the second one has to be x squared plus our 2x plus 2. So you can verify to say you cannot factorize this. There are two, you cannot factorize this, so that means to say it's irreducible. Then you are going to have on top, since this is ax, you can now have c. So so it should be ax plus b. Then here we are going to have cx plus our d, like that. So just think of it as the linear equation. That way you will never fail any question. So from there we are going to multiply the denominator. Then we are going to have, so what we are going to have is we are going to multiply. So the denominator is x squared plus our 2x plus our 2, like that. Then we are going to have our squared, like that. Then when we do that, we are going to get something like So we are multiplying throughout. This value, when we multiply, it shall cancel with this. So we are going to have a 7x to the power 3 plus our 16x to the power 2 plus our 20x plus our 5, which should be equal to, we are going to get our a x plus our b. So when this and this cancels, we are going to cancel like that. Then we are going to remain with, we are going to have our x squared plus our 2x. So only one term is going to be cancelled there, plus 2x plus 2 like that. Then we have plus, already, if the power here is 2, if the power here is 2, it will cancel together with this. So we are going to remain with cx plus d there. Then what we are going to do is that we are going to say, so we have 4 letters. So since we have 4 letters, there's no way we can eliminate 3 letters at the same time. So what we are going to do is that let us expand. So this side we have our 7x to the power 3 plus our 16x to the power 2 plus our 20x plus our 5 should be equal to, so expanding this side, let me reduce the size of this. So that will give us, so a multiplies everything, that's the meaning. So we have our ax multiplies, we have our x squared plus our 2x plus our 2, then we have plus our b multiplies everything, so we have b times x squared plus our 2x plus our 2 like that. Then what we are going to get is plus our cx plus our d like that. So this is going to give us a value that is equivalent to, we are going to get 7. So this side we have our 7x to the power 3 plus our 16x to the power 2 plus our 20x plus our 5, which should be equal to ax times that. We are going to have our ax to the power 3 plus ax times this. We are going to have our 2ax squared, this times this. We are going to have plus our 2ax like that. Then we are going to have b times x squared. This is going to give us plus our bx squared. Then we have plus our b times this. We are going to have our 2bx. Then b times 2, we are going to have 2b like that. Then we have plus our cx plus our d like that. So from here we are going to compare. So the power 3 shall be equal to the power 3. So that's the only term there. So we are going to say 7x to the power 3 should be equal to ax to the power 3. We cancel. We are going to remain with our a is equal to 7 like that. So same approach, we are going to also compare other things. So the other terms that we are going to compare with are the one with 16x squared. It should be equal to all the terms that have got our x squared like that. So all the terms that have got x to the power 2 shall be equal. So we are going to have our 16x squared should be equal to, we are going to have our 2ax squared, then we have plus our bx squared like that. Then we divide our x throughout, x squared throughout, these will cancel. So we are going to have our 16 should be equal to 2a plus our b. And our a is equal to 7. So we are going to have 16 should be equal to 2. Where there is a, we put 7 plus our b like that. So our 16 should be equal to 14 plus our b, which is going to give us a 16. This 14 comes here. We are going to have minus 14 should be equal to b. So our b should be equal to positive 2 like that. So we have a positive 2, we have a positive 7 like that. Then last but not the least, we are going to, we have 2 letters. So we are on the 20 now. So this one shall be equal to all the terms with just x. So we have these terms without x. So we are going, or with just one x to the power 1. So we are going to compare and say 20 should be equal to, okay, so I'll write here, then move it. So we have 20x should be equal to, we have our 2ax plus our 2bx plus our cx, like that. So here where x is common, so we can cancel it throughout, so that we remain with 20 should be equal to 2a plus our 2b plus our c, like that. We know that a is equal to 7, so we are going to say 7 plus our 2, our b is equal to 2 plus our c, which is going to give us 20 is equal to 2 times 7 is going to give us 14, plus we have our 4 plus our c, like that. So our 20 should be equal to, we have 14 plus 4 will give us 18 plus c. We take the 18 this side, we are going to get 20 minus 18 should be equal to c. Then our 2 should be equal to c. So we have found our c is equal to 2, our b is equal to 2, our a is equal to 7, like that. Let's find d. So for our 5, it is going to be equal to all the terms without x. So these terms are, we have this one and this one only according to this. So we are going to say our 5 should be equal to 2b plus d. Then we know that our b is equal to 2, so our b is equal to 2. Then we have plus d, like that. So we have our 5, then we have should be equal to 4 plus d. So our d value should be equal to positive 1. If this comes here to be 5 minus 4, which is equal to positive 1. So our a is equal to 7, our b is equal to 2, our c is equal to 2, our d is equal to positive 1. Let's just write the final answer now. So we are going to put our a is equal to 7, it's attached with x, then our b is equal to 2 over our x squared plus our 2x plus our 2. Then we have plus our c is attached with 2, also we have 2, it's attached with x, plus our d is 1. Then we have over our x squared plus our 2x plus our 2, then we square this. So now let's deal with our last part with improper fractions. So how do you deal with improper fractions, or rather what are they to begin with? So improper fractions are those that have got, on the denominator there is a less power as compared to the numerator. So like for example, if you have your x to the power 3 plus that over our x plus 1, then we have our x minus 1. So already you know to say if you expand this, it will be a quadratic, which will give you the highest power to be x to the power 2. Now this already is a problem because the numerator has got the highest power of 3, so it is an improper. So each and every time you have an improper, the thing that you are going to do is that, so don't get confused. Sometimes maybe you might have x plus 1, let's say this one is squared times x plus 1, then it's squared. That means to say when you expand this will be x to the power 2, this will be x to the power 2. When you multiply these two, it will be x to the power 4. That means to say it is a greater power. However, for this one, it is direct to the extent whereby when you multiply, you are going to have a quadratic equation. So how you do with this one is you do your long division. So your long division, you get, so multiply this and this, so we are going to have x plus 1 times our x minus 1. So you can do your multiplication, but this is a conjugate. It is the same number, the sign is different. So just multiply first number with first number. So we are going to have x squared, last number with last number, we are going to have minus 1, like that. So you can only do this if it is a conjugate. Then what we are going to get is that we are going to divide, so we are going to have something like this. So we are going to have our x squared minus 1, like that. Then we have a number, it is x to the power 3 plus 0x to the power 2 plus our 3. Don't forget the 0x like that. We have another one which is our 0x plus our 3. They have to descend. So we have our x to the power 3. So our x to the power 3 divided by our x, this will give us x to the power of 2. So it will be our x to the power of 2, our x to the power 3 divided by x to the power 2 is equal to x to the power 1. So we have x to the power 1. We multiply this and this, it will give us x to the power 3. Then this and this. So automatically, if it is -1, we are going to look at the place value. So the place value, this times this is x. So it's more like the like term is here. So we are going to say minus x like that. Then we are going to subtract, no more long division. So we have our x to the power 3 minus x to the power 2. It is a 0 here. Then our 0 minus negative, it will be positive like that. So here it's not supposed to be 0x, but x times this is positive, or negative x like that. Negative times negative is positive, so we have positive x. We drop the 3, it will be plus our 3 like that. Now what I like to do is that just spell the word code. So we are going to have the word code like that. So this means that we are going to have your quotient, which is the result. You add it with the remainder over the divisor, the number that was dividing. So we are going to have, for this problem, we are going to have something like this. So remember, this one is x to the power 3 plus 3 over, this is x, we said that this is x squared minus 1. So this, the word quotient, which was our result, which is shown here. So the quotient, which is here, so you are going to put your quotient, then add plus your remainder, which is the remainder in this case is this one. Then you are going to say your x plus your 3 over the divisor, which is this one. So over your divisor, which will give you a value of x squared minus our 1 like that. From here it becomes very, very simple. All you have to do is find the partial fraction of this. So it will be our x plus our 3 over our x squared minus 1. So this one is the same as, if you recall, we said it's x minus 1 and x plus 1. So how we are able to determine this is that this is the difference of two squares. So we have our x minus 1, we have our x plus 1. So this should be equal to, that is when it is factorized, this should be equal to, we have our a over the first denominator, which is our x minus 1. Then we have plus our b over the second denominator, which is our x plus 1 like that. Then what we are going to get is that we are going to get a, so we are going to multiply now. We are going to have our x, we are going to have our x minus 1, then we have our x plus 1. So this is going to be equal to, so this cancels with this, so we are going to have our x plus 3, then it is multiplying throughout. Then for the second part, this cancels with this, so we are going to have our a, open brackets, we are remaining with our x plus 1. Then we have plus our b, so our b on that one cancels with this, cancels with this, so we are going to have b times, we have our x minus our 1 like that. Then what we are going to have is, we have our x, so here we can say let your x be equal to, we are going to say let your x be equal to positive 1, so that we eliminate b. So this will be 1 plus 3 should be equal to a times, we have a 1 plus 1, then we have plus b, 1 minus 1. So if we put 1 there, so it will be 4 should be equal to 2, because 1 plus 1 is 2, a. We divide by 2, we divide by 2, our a value should be equal to positive 2 like that. Then when we do the positive 2, we go to our b. When our x should be equal to -1, so that this time we eliminate our a, -1, that will give us 0. So we have -1 plus 3 should be equal to a, -1 plus 1. Then we have plus our b, -1 minus 1. This is going to give us a +2 should be equal to, we have a 0 there. Then we are going to have a, so here we have 0, then we have plus b, -1 minus 1 is equal to -2, like that. So we have 2 should be equal to -2 by b, it will be -2b. We divide by -2, we divide by -2. Our b should be equal to -1, like that. So we have our b is equal to -1, our a is equal to +2. Now we can just write everything. So we have our a is equal to +2, our b is equal to a -1, like that. So this is what we had. Then here you can just put the x minus 1 and stay. Okay, so we for this one we said this is the same as plus our a over x minus 1, then plus our b over our x plus 1, like that, which is this one. So this one, we have this a over this, b over that. So this is what we have. So we can now just write, so we have our x, our a is 2, so we have 2 over our x minus 1. Then we have our b is equal to -1, so we have -1 over our x plus 1, like that. Let's look at this other one. Let's say we have our x to the power of 2 minus 2 over, we have minus our 2 over our x plus our 3. Then we have our x minus 1, like that. So let this, if we have this already, this is an improper because the power of the numerator and the denominator should not be equal. So if you multiply this and this, it will give you x squared. So we have to use the long division again. So we are going to say, let us multiply this. So we are going to have our x plus 3 times our x minus 1. We are going to expand it first. So the first number multiplies everything. So we have, then the last number also multiplies everything. So we are going to have x by x, it will be x squared. This by this, it will be minus x. 3 by this, it will be 3x. 3 by this, it will be -3, which will be our x squared. Then we have our plus 2x. Then we have minus our 3, like that. So if this is what we have, the equation becomes equal to our x squared over x squared minus 2 over, we have our x squared, then we have plus our 2x, then we have minus 3. So the powers are not supposed to be equal, therefore let's use the long division. So we put the one that's dividing, x squared plus our 2x minus 3, then we get our x squared minus 2 there. Let's just follow. We have 0x plus our 2. Is it plus or minus? Minus 2. So we are going to put minus 2, like that. Then x squared divided by x squared, that's a 1. 1 times x squared is x squared. 1 times this, it will give us a positive 2x. This times this, it will give us -3, like that. So with that said, we are going now to apply a negative. X squared minus x squared, that's a 0. 0 minus 2x, that will be -2x. -2 minus -3, that is -2 minus -3, it will be -2 plus 3, which is going to give us +1. So we are going to have +1. You cannot divide 2x divided by x squared, no. So that means to say we are done. So from here, this is the simple way I've taught you. Just spell the word code, small letters, then we have code like that. So the quotient, which is the result there, we are going to have our quotient like that, then we add plus our remainder, which is this one. So this one can be written, let's begin with our positive. So this one is the same as 1 minus 2x. It's still the same, so it is still the same as that. So we have our 1 minus our 2x, then over the divisor, which is this one, dividing. So we have our x squared plus our 2x, then we have minus our 3 like that. Okay, so now we have this. Now this one was initially, we have 1 minus our 2x. In its factorized form, this one is we had x plus 3 and x plus 3 and our x minus 1 like that. So this is what we have. So what we are going to do is that, so 1 minus 2x, so this is going to give us a value that is equivalent to, so we are going to apply the partial fraction concept. So what we have is this 1 minus our 2x over, we have our x plus 3 times our x minus 1 should be equal to, we have our a over the first denominator, then we have plus our b over the second denominator like that. Then this one, let it be multiplied by what we are going to say it is. So you have our x plus 3, then we have our x minus 1 like that. So when we do that, we are going to have our 1 minus 2x, because this one and this one will cancel, should be equal to a. This one and this one cancel, so we are going to remain with our x minus 1. Then we have plus our b. Our b, we are going to multiply it with this, since this one and this one will cancel. Then what we are going to have is, after having this, we are going to get a value. We are going to get a value now. So we are going to say when x is equal to positive 1, we are going to have 1 minus 2, where there is x, we put 1, should be equal to a, 1 minus 1, plus our b, 1 plus 3, which will give us 1 minus 2 should be equal to, we have a, 1 minus 1 is 0, plus 1 plus 3 is 4, so we have 4b like that. 1 minus 2 is equal to negative 1, should be equal to, this is 0, so we have our 4b like that. We divide over 4, our b value should be equal to negative 1 over our 4 like that. For the second part, we are going to say when x is equal to negative 3, we are going to have our 1 minus 2, we have negative 3 should be equal to a, negative 3 minus 1, so that this goes, so we have plus b, negative 3 plus our 3, this is going to give us a 1, plus we have our 6 like that, should be equal to negative 3 minus 1, that will be equal to a negative 4 like that. Then we have a plus b, then we have 0 like that. 1 plus 6, it will be 7, should be equal to negative times that, it will be negative 4a. So we have a negative 4a, negative, we divide. So we have our a is equal to 7, we can just throw the negative up, so 7 over 4. Then we found our b was equal to a negative 1 over 4. Let's just now substitute. Then what we have is 1, our a is equal to this value, so how we did the last time, we have a negative 7, we throw the 4 on the denominator, then we have our x plus 3 like that, then we have another one, negative 1 over, we have our 4, which is our x minus 1 like that, 1 minus 1 like that. So this is what we have for that as our final answer. So let's look at our last question. But to avoid this video from being 2 hours, what I'm going to do is that I'm going to give you some pointers on how you can solve this question. So already the power is 4, meaning it's even. So what we are going to do is that so we can make a difference of 2 squares. So this is the same as x to the power 4 is the same as x to the power 2 to the power 2 minus 1 to the power of 2, like that. So this is basically it. Then even if you do this, it's still the same for 2. Then what we are going to have is that taking this one, we are going to have x squared minus 1. Then taking another one, since there are 2 of them, we are going to have x squared plus 1, like that. So that's how the difference of 2 squares work. So we are going to substitute it there, and we are going to have x cubed. Then we have minus 5x squared. Then we have minus x minus 3. Then we have over, we have x squared minus 1, as we have said. Then x squared plus 1, like that. So what we are going to have is, already this one is a difference of 2 squares. So x squared minus 1 is equal to, we are going to have x minus 1 and x plus 1, like that. So this means that we are going to have something like this. So we have our x cubed minus 5x squared minus x minus 3 over, we have our x minus 1, x plus 1, like that. Then we have x squared plus 1. This is irreducible. So this is equal to a over the first denominator, which is our x minus 1, plus b over the second denominator, which is our x plus 1. Then we have plus, since this is irreducible, we are going to say cx plus our d over, we have our irreducible, which is our x squared plus 1. From here, what you are going to do is multiply this throughout. Multiplying this throughout, you are going to get, so from there you are going to multiply the denominator, which is our x minus 1 times our x plus 1, then times our x squared plus 1. This will give us a value of, so already this and this will cancel, so we are going to have our x cubed. Then we have minus 5x squared minus x minus 3 should be equal to, so here this one cancels, so we are remaining with our a, open brackets, our x plus 1. Then we have our x squared plus 1, like that. Then we are going to have our b, this and this cancels, we are going to have b times, we have our x minus 1. Then we are remaining with our x squared plus our 1, like that. Then we have plus our c. We are going to cancel this and this, so we have our c, in fact it's cx plus d multiplying with whatever will remain, so we just cancel this, so we are going to remain with our x minus 1. Then we have our x plus 1 as the remaining factors. So now what we are going to do here is that so just from here we can let our x be equal to positive 1, so that we eliminate this term, we also eliminate this term. So it will be 1 to the power 3 minus 5 times 1 minus 1, like that. Minus 3 should be equal to a. Then we have 1 plus 1, we are just replacing 1 squared plus 1. Then we have plus our b, we have 1 minus 1. Then we have 1 squared plus 1 there. Then what we are going to have is so we have plus 1, like that. Then we have plus, we have our c 1 plus our d. Then we have our 1 minus 1. Then we have 1 plus 1, like that. So this is going to give us 1 minus 5. Then we have minus 1. Then we are going to have our a, 1 plus 1 is 2. 1 squared plus 1 is still 2. Then here we are going to have plus our b times 0. 1 plus 1 is 1. Then we are going to have plus our open brackets, we have c plus d, then times 0 times 2. So wherever there is 0, it is going to be 0. So we have 1 minus, so minus 3, minus 1, negative 5 minus 1, that's negative 6, minus 3, that's negative 9. 9 plus 1, it will be negative 8, should be equal to, we have 2 times 2 is going to give us 4a. Here it's 0 throughout, 0 throughout. So we divide by 4, we divide by 4. Our a value should be equal to a negative 2, like that. So this one shall be done in the next video as a part. So now, if you are trying it out, what you can do is just expand everything, then use the method of comparing, because there is no other way of eliminating two components at the same time. If you put a 0 here, it will eliminate c, but it won't eliminate d, like that. So you need a way of just comparing. Now, to avoid the video from being too long, we are going to end on this one. So just to help you expand this and this, you are going to have something like this. We have a, then we have x times x, it will be x to the power 3. This times this, it will be plus x. Then this times this, it will be x squared. This times this, it will be plus 1. Then we have plus, then here, this times this, it will be, first outside we have a b. Inside we are going to have x to the power 3. This times this, it is going to give us x. This times this, minus x squared. Then we have this times this, we are going to have minus 1, like that. So this is in one bracket. Then we could have plus our cx plus d, which is going to give us this. So these are conjugates, so just multiply that. We are going to have x squared. This times this, we are going to have minus x, like that. Then from here, what you're going to do is expand it. So expanding this one, we are going to get ax to the power of 3 plus this times this, it's ax. Then this times this, we are going to get plus our ax squared. Then a times that, we are going to have our a, plus we are going to have our b times this, we are going to b times x to the power that, we are going to get our bx to the power of 3. Then this times that, we are going to get plus our bx. This times this, we are going to get minus our bx squared, like that. Then we have, so remember this one is at the ends there, so we have a 1 there. So we have b times this, it will be minus our b, like that. Then we are going to continue plus, if I am to multiply direct, this one will be cx times this, it will be cx to the power 3. Cx times this, we are going to get cx. D times dx squared, we are going to have dx squared. D times negative 1, it will be minus our d, like that. So what we have is, let's see, are there any terms that can be simplified? So there's nothing that can be simplified. From here, let's just finish the question. So on this other side, we have our x to the power of 3. So we are going to write our x to the power of 3 minus our 5x to the power 2 minus our x minus our 3, like that. So from here, all you have to do is just compare the terms. So the ones with x to the power 3, let them be equal. So we are going to take all of these. So that means to say x to the power 3 is equal to ax to the power 3 plus our bx to the power 3 plus our cx to the power 3. Therefore, this is going to give you something like this. So 1 should be equal to a plus b plus our c. Then for the other part, we are going So this one will be equal to all of them that are squared. So we are going to get these. So we are going to have a negative 5 like that, x to the power 2. So we can have, let me leave some space, negative 5 x to the power 2 should be equal to all the terms. So we have positive x squared. We also have a minus a bx squared. Then we have plus our dx squared like that. So this is going to give us something like this. So we have negative 5 should be equal to a minus b plus our d like that. Then we are going to have for our last part, okay, not our last part, for this other, we are going to get this and get all the terms that are just having x to the power 1 like that. So this is going to give us, we have a negative x is equal to, we have ax, we have plus bx, we have minus cx like that. So when we do that, we are going to end up with this situation. So we are going to cancel the x, which will be negative 1 is equal to a plus b minus c. So already having these two equations, this one and this one, can be solved simultaneously. So what we are going to do is 1 is equal to a plus b plus c. We also have our negative 1 should be equal to, we have a plus b minus c. Adding these two equations, so we are going to have 1 plus negative 1, that's 0, because these are different, so meaning to say you can just add them. So we have a plus a, it will be 2a, b plus b, it will be plus our 2b like that. Then we are going to take this the other side, it will be negative 2a should be equal to 2b. Remember a, we found it to be equal to negative 2, so we have negative 2, then a is equal to negative 2 should be equal to 2b. Negative times negative is positive, 2 times 2 is 4, so we have our 2b like that, over 2, that will give us a value of b to be equal to, we are going to have b should be equal to positive 2. Then we are going to, now that we know our a and our b and our d, so it's good to find one value, but if you can't, you just have to use the simultaneous equations. So getting this equation, we are going to get a negative 5. Negative 5 is equal to, we have our a minus b, is it minus b plus d like that. So a is equal to negative 2, we are replacing b is equal to positive 2 plus our d like that. So we are going to have negative 5, so it will be negative 5 should be equal to negative 4 plus d. We take the negative 4 this side, it will be negative 5 plus 4 should be equal to d. So we are going to have negative 1 should be equal to, we are going to have a d like that. Then to find our c, we are going to get something like this. Get all the terms that are without x, which are remaining like that, and equate them. So the terms that we are going to get are negative 3 should be equal to, we have a, then we have minus b, then we have minus our d like that. Where's our c? Where's our c? Where's our c? Where's our c? Have we found? We have found a, the value of a. Okay, we want the value of c, of which if we do that, it's not going to give us. So we can even get this one that has got c and say 1 should be equal to, 1 should be equal to a plus b plus c. So 1 should be equal to, our a value is negative 2 plus our b value is equal to positive 2, should be positive 2. b is positive 2, then we have plus our c. So we are going to find that 1 is equal to 0 plus c, so c is equal to positive 1, like that. So this is the value of our c. So our a is equal to negative 2, b is equal to positive 2, c is equal to 1, d is equal to negative 1. So therefore what we are going to do is that let's just write it. Let's write our final answer. So we are going to replace. So a is equal to negative 2, so over x minus 1, plus our b is equal to positive 2 over x plus 1. Then we have our c is equal to, we found c to be equal to 1, so we are going to have plus x, just we can't have 1x, so we have, then our d value was found to be negative 1, so minus 1 over our x squared plus 1. So that is how we go about that one. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.